Welcome to Turn Right Machine Works. My name is Keith, and today we're continuing on the Mattracks project. Alright, we've got our slugs in the lathe here, and we're just about done. We're just going to break a surface here, and we're going to put another center drill in here. We're kind of undecided right now. We're going to put a couple holes in to hold the slug down to the mill table, and we got to put a couple threads in here to hold the friction or holding plate down on the top, because we're going to be sandwiching this bore here on the Mattracks housing. All right, so let's go ahead and let's get started here. We're going to bring in the tailstock, and we're going to put in one more center drill. We're going to set up, and we're going to start turning the diameter down. We have a diameter here that we're going to try to come down to, and we were averaging between 4632 and 4631, 4633 we see over here. So we're right in that ballpark right there, and we're going to get it to just slip through there, and so we have no rocking. And then with the clamping procedure, we're going to be able to hold these things in a horizontal plane on the mill table, and then we can start working on them. Actually, we can hold them in mini tables. We could actually hold them in the drill press if we want to do a drill and ream. We can hold them in the K&T or in the wannabe. All right, we've got both these faces. This face, we're not going to chamfer this one, but we're going to put a quick center drill in here, and then we're going to do some turning right here. And I think we're going to double check our dimensions right here, and our jaws are like 2.7, and I think our dimensions for our offset was 2.950 to be on the safe side. So we'll be out in this area right in here, so that we have a shoulder for that bore to come down and register and hold it up off the table, and have that support down to the table below the bore. And we're going to take a look at how it's running. And it looks fairly good. I went ahead and center drill it in the center just in case we decide to just do one bolt holding it down, or if we need to turn it or put it back in and align it, and any kind of different machining, we're going to want probably to hold it with the center, because that center is going to be true with our diameter we're going to turn. And sometimes when you slip something in and out of the jaw, by having that center in there, you can relocate that right back in there. But I think we'll be able to slip our Mattracks over this and test it right here, so I don't think we're going to have to take it in and out. I just want to put that in there, so if I needed one, I had one. We may be going for a full 4-hole pattern, 2 tapped, and 2 clearance for Allen's socket heads to go down and grab T-nut slots in the table. Alright, we're going to turn this around. We're going to change this out, and we're going to go ahead and use high-speed steel here for turning our aluminum. We don't have that much to actually turn off, and it is less gummy. We're just going to visually look at our center height there, and we're going to do the scale check on the outside. This tool bit, we just brought this in here, and of course we want to check it for center, and it looks, the scale's leaning in. So that means we're high. So we're going to go ahead and we're going to back this off, and pretty close. Look, sometimes your scale's a little bent, so you know you can trade it off. But both ways there, it's slightly on the leaning out, which means we're slightly below center, and we're going to let it fly like that. We're going to be taking from 5 inches, what we got now, down to, like I said, 4, 6, 30, the low 30s there. so we get a slip fit. And we're going to go ahead and turn it to 400 deep here, maybe a little bit shy of that, maybe 2 3/8. So let's touch off, and we're going to get going on that. And we're just going to go with a light feed, and we're about 450 on the RPM. 50 on the depth. We set the 0 there, plus a couple from touching off, and here we go. Stringy chips, okay? You got stringy chips, you could actually take a little bit more on your feed. You want to get those things to curl and break and you know, not become so dangerous. Long stringy chips are you know, dangerous for the most part. Okay, we're going to step up the feed a little bit. We're going to see if we can get them to curl and go one direction, or have some other kind of shape that's not so stringy. Still the same thing. Okay, now we're going to go ahead and we're going to back up just a little bit more. See if we can't get those to break some chips. Same thing. Now, you may get to a point where you can't break a chip, no matter what the depth you're taking and the cut, and you're going to have a string scenario. Okay, you can put somewhat of a cut in the top of your tool bit, and you can get that thing to form and break. You can change a little different angle and things like that. Just for the benefit of the doubt, let's just say we weren't going to turn it with high speed. Let's say we're going to go ahead and we're going to run a regular insert here. And this is just one of my Sandvik inserts. I'm nothing fancy about it. My all-around turning insert. But it has a positive action to the undercut of the insert itself. Now we'll try the same thing. Okay, now we're breaking the chip with no problem. Alright, so I'm going to go ahead and I'm going to run this here, and I'm getting a nice finish here too. You know, there are pros and cons to the high speed or inserts, and a lot of people go, do you need a certain kind of insert? Not all the time. Some inserts will work better than other inserts. And I'm not going to get in, I'm not the expert on inserts. Alright, I pick something that works for me. Okay, sometimes when us old jobbers get something that works, we kind of stick with it for a long time. And, you know, hey, we're grateful if we try something new and it's really doing a lot better and getting a job done. That's what it's all about. But when some things work, you get in a little rut. I'm not saying that's a good thing or a bad thing. I'm just saying that I do know what happens. All right. We're going to go ahead and we like this feed combination. We're going to go with it. All right, now we need to reset 0 because I didn't touch off and set this. Just scaling, we're like 1/600, and we kind of like that depth, and we know that depth was roughly about 50 thousandths, but we're going to go ahead and we're going to retouch. We're going to go ahead and start again so that we got our depth and distance and everything else figured out, so that we can take like several cuts of 50 thousandths on the depth there. Okay, come over here, touch, let's go to 0, we'll take our 50, we're going into 100, we'll come back to our 50 in a minute. I just want to touch 0, okay, 0, come back out, come back in, come into our cut, okay, we'll take it from there. That's 350. important part. Keep your face out of in line of your chuck and your debris that flings out from it. All right, nothing worse than getting slapped in the face by a chip. Well, there is a couple things worse, but all right. I know we got to go more, but I just want to see where we're at and kind of the increments that we're going. And we're at 4,800, okay, and 2,000. So. That just means that our 50 and 50 are like right on the money. For the most part, that's a pretty clean breaking chip off of there. Alright, and we're just going to quick scale it here, okay, 700. Alright, now we're going to 630. So we're going to go ahead and we're going to back on down now. We're just going to go ahead and we're going to take like a 20,000ths cut. Should bring us to something like 4660, somewhere around in there. About 32, 33,000ths to go. Okay, 32. This is probably going to be tight, but we're going to back this off and we're going to go ahead and try. We're going to try one of the housings here, and she's tight. We're almost the size. We're going to take another 2,000 per side. I went ahead and came out on that face as well, so I think we're real close, and we may actually be fitting on here. And okay, we should be a split fit now. I like that. This is set down in about 50,000. 50,000 or a little bit less. So we'll be able to make a flat plate right there that will hold that down. Alright, I'm happy with that. I think this big one is good. We're going to go ahead and turn the small one, and then we're going to get on over into the mill. Alright, one last thing before we pull this out and put in our next piece is go ahead and kiss off the corners, or break the corner slightly there, and we're seeing if we can come in with this little bit here. There we can. Alright. That's great, nice. Okay, we're going to go ahead and pull this out and change it out. Two hands on that shoulder, boy. Alright, I put this is just a bronze billet that I put in here, and it's like some of my other pieces and chunks of material I have laying around that I've cut off and made something else from it, but it hangs around here, and I've got it faced off, and I was turning something over there, and it's got a flat face, and I put it against the chuck, and I just came over here and I just skimmed this because I'm going to friction drive this piece against there so that I have the whole slug out here in the open so I can do some machining. And the way I'm going to do that is I made sure that my tool bit and everything else comes out here past here. I bring the tailstock in, and I just have to lightly tighten it. I have to grab it with my left hand there because my shoulder is, I'm not able to pull on that anymore. And also at the same time that we're talking about the tailstock, this is the original drawbar, and shortly after I was doing, I guess it was the tub grinding shaft, the jack shaft what we had in for the tub grinder. Just shortly after that, I just tightened it, and all of a sudden I snapped, and it was started sometime before, but it finished breaking off. This is the original draw bolt, and it was left hand. After going back to a right hand and having to pull on it and push on it, pretty soon I'm going to be making another left hand draw bolt for my tailstock, and it makes a big difference on your leverage of loosening and tightening, and not having to change your stance. Right now I have to change my stance anyway, because now when I'm going to tighten it I got to reach in here with both arms, just because I can't do that with my right arm yet. I'm still, it's going to be a while before that's back to normal. Alright, so with the tailstock locked down, I always start my friction drive. I kind of like leave it loose. I get the chuck spinning, and I have my quill tensioned slightly, so just lost my little floodlight. Alright. Just found out why. I had an extension cord draped over my wood stove here, and I just put some wood in here and lit it off so it's pre-smoked the stack. Well, I pre-smoked my extension cord, so I'm out on the extension cord. It's probably 20 years old, and should have an electric outlet over here. And that cord was to come over here and run the fan on my heater, but right now the fan on my heater is not in good shape either, so maybe I can work both of them at the same time. But at least now I know I can unplug that extension cord and I'll have the light back on the lathe. Alright, there we go. It's hard to tell if anything's stinking when you're doing that, because everything stinks when you first light off a stove that's been sitting all summer. Critters and all that kind of stuff been living in it. Alright, here we go. Now we screwed in and tensioned in the tailstock, and this is nice and solid. And I like how it's turning. Alright, now we're going to go ahead and we're going to do the same thing. We're going to take this diameter down to our bore size, about 2 3/8 in depth, and we should be good to go. diameter turned to the size, and now we're going to go ahead and break our two edges here, again just like the other side. Alright, and now we're going to pull this out and check our fit. Pretty cool. I hope they all fit that way, or just a, well, actually when it's aligned, pretty good. I got a couple thousandths clearance in there, and I just don't want to have any binding. I want to be able to clamp it down, hold it, do the machine work, and then release it. All right, now we're going to go ahead, and I think I'm going to set up the dividing head so I can get 4-hole pattern going in here. And we'll get these mounted down to the table, and then we're probably going to go into plasma cutter. We're going to cut out some flanges that actually it goes in the way that I did first had it in here, but this is down below that surface, so we need a round disc with that 2-hole pattern, and we can tighten that down, and the other 2-hole pattern will tighten in on the table. And then we'll be holding these things real rigid. Then we can go with screw jacks or machinist wedges, those kind of things, to toe clamp the other sections, and we can start going for our bores. Alright, I pulled my vise off of here and set it out of the way. And I have the height problem that's somewhat of an issue, stacking up the index head, the table all the way down, and drill chuck and the length of drills that you need. And what I plan on doing is actually putting 2 holes so that I can put these 2 Allens down in here and actually hold these 2 units. This one's not such a problem. I mean that this is not a great depth here, but this one here has to come on down in here. And I want to do the same pattern, the same plate. We'll be able to lock both of these in, because we're going to go 2 hold down bolts, and then we're going to go 2 smaller bolts. They could actually be just standard 1/2-inch cap screws, hex head cap screws, and hold that plate down. So I'm going to go ahead and set up the index head right on the drill press here. That way I'll be able to index all 4 holes on the same circle and keep uniformity that way between parts. But also I have almost, for the tools that I have, almost endless on the height and clearance and all of that. Now when I went ahead and swapped this table out from the original one of the main reasons why I did the swap was because the T-slots in this faceplate. And this faceplate is exactly the same thickness, exactly the same diameter, everything as the original faceplate that went on here. The importance of the T-nuts is really important. I think it's great to have T-nut capabilities to do toe clamping and through clamping and things like that, as well as having the regular slots that are in these tables as well. Just like I used the faceplate there on the lathe to hold that bell housing for the Cummins diesel. Alright, now when I put this drill press together and I was waiting for this or that, I went ahead and I machined my own T-nuts. And when I machined the T-nuts, I machined them all the same width and characteristics that way, but I tapped them out for different sizes. Now I'm going to put a pair in here that I actually tapped out for 1/2 inch, and that's what I'm going to use to hold down the dividing head. And the 5/8 here that normally hold my pomegranate vise down, I drilled and tapped 2 holes in the table, and then I used these, and now I'm able to slide that nice vise in and out. So I just want to point out that T-nuts, and also mine doesn't, but my 4-jaw, I wish it did, and I may actually, I don't know if I'd actually cut T-nuts in there, or if I'd just go out and I'd buy another 4-jaw that had T-nuts in it. I would like to think that the jaws are so used and bell mouth from the prior owners there, I'd have to get in and remachine the jaws themselves, and to have a value that I would validate cutting T-nut slots in it. Alright, so we got these here, and I have to clear the way so that I can get a short pick on that index head there, so I don't mess up my shoulder. Alright, did that without hurting myself. And we're going to go ahead and I think, yeah, this will work. And I'm going to slide this over so I can look. I just want to kind of look to make sure that we are eyeballed pretty good center there. Couple washers on each just so we don't have to screw the nuts down so far, and we don't have a big thread hanging out of the nut. Alright, alright, before we go any farther, I just want to make sure that I've got this index on 4. I forgot to check the masking plate or whatever I had in here. It is on 90, so 1, 2, 3. Okay, we are set up with a 4-hole masking or 4 indexing plate. All right, we just want to, we're doing the short one here first, just convenience for setting it up, and we're putting 2 of our holes in line with one of the jaws so we can freely go through our 2 holes, and we'll drill them almost all the way through, and then we'll just slip and hold the last one there so we can go through to pierce the underside. There's no real need for super accuracy on these. These are hold down holes and then clamping holes. The location of the center point and everything else like that can be judged off of the center drill that we left in there as well. Alright, we're just going to give ourselves an even uniform pattern here, and it looks like 3 1/4 is going to be our hole center. And now we're just going to go ahead and we're going to jockey our table around and lock it down to where our tap follower point will indicate that hole. And that's pretty close. We're going to go ahead and lock the table, and we can do the rest of our jockeying around right here with the T-nut, the play in the nuts and bolts for the T-nuts there. This old drill press, and when you tighten up the knee, it does tend to pull it out slightly. So if you're really precision locating, there you got to leave yourself a little bit of room for air. And when you're working off of one side, it's not too bad because you can rotate this as well, like that. Alright, and then we get our 7/8, and we had just lightly set these anyway, and we can just bump this out, and that looks good for all purposes. Alright, let's find ourselves starting drills and go to it. Alright, touch off here. Okay, that looks good. Okay, we're just going to go ahead and spot ourselves a couple starting points here. We're going to go give our Aluma tap here. This just really kind of helps it out. gonna rotate it around. We're just giving us pretty much a starting hole in this in 4 points here. Now we know this drill press turns way too slow for, you know, what aluminum can be drilled at, and we're gonna go ahead and we're going for our 2 side ones here first, and we're gonna want to drill and tap our other ones for 1/2 inch. So I don't want to confuse our through holes and our tapped holes. So I'm hitting the 2 here first with the 1/2 inch started hole. All right, now we're going to go ahead and we're going to do these 2 here with 7/16 or 27/32 that are tap size for 1/2 inch. Yeah, 27/64. But we're going to tap. We're going to drill and tap these. I'm going to go dress this off on the stone there. All right, we just kissed that off on the Leslie sharpener, and a little bit of a rollover piece there. That's some of what was in the caught in the shank there from our last drilling. It was pretty well clean. All right, now we should. Yeah, we know we're gonna probably want to go about 1 inch or so down, and we're gonna tap it. So let's go ahead and drill them out 1.5 inches deep here. Kind of set this at a line here.